If I take the letters A, B, and C, I can rearrange them 6 ways. Those are arrangements. Of those 6 ways, most of them have something still in its original spot, like ABC has the A in the first spot, ACB has A in the first spot, CBA has B in the second spot, BAC has C in the third spot. ABC has a lot of things still in their original spot. All that remains are these 2 guys. So we say there are 2 derangements for set size 3. A derangement is a rearrangement of the objects so that nothing remains in its original spot. We could even say D3 equals 2. If I only have 2 things, there are only 2 ways to arrange them at all, and of those 2, only one of them is a derangement, so we can say D of 2 equals 1. But it gets more complicated when you try to get derangements for bigger numbers. So the next question is, what's D of 4? Well, there are, for 4 things, there are 24 ways to rearrange them. So here's the 24 arrangements of 4 letters. But most of them, like all of these guys, have A in the first spot. And scanning through the list, I'm crossing off the guys who are left who have B in the second spot. And now I'm crossing off guys that are left that have C in the third spot. And now of the guys left, I'm crossing off the guys who have D in the fourth spot. And not so many are left. 1, 2, 3, 4, 5, 6, 7, 8. Should be 9. I missed that guy. So we say that D of 4 equals 9. And it starts getting pretty difficult, even to do this one, to know that D of 5, for instance, is hard. Whoops, D of 5, it's not that easy to figure out that it would be out of the 120 different ways, there's actually 44 ways. How would we get that? Well, Euler came up with a what's called recursive way of doing this. The idea was, if I have 5 letters, A can't be the first letter in his derangement, so let's swap him with somebody, like swap him with D. Now, I can leave D in this place. So there's going to be some derangements that have D in this first place. So then I just have to swap around those other guys, which I can do 9 different ways, because I already figured out D4. However, I'll have left out some derangements because A was actually allowed to be in this spot. So now I'm going to let D and A stay in these 2 spots and just derange the 3 BCEs around, and there are actually 2 ways of doing that. So there are 11 derangements that have D in the first spot. Some have A in this 4th spot, and some don't have, some have A in the 4th spot, that's these, and some don't have A in the 4th spot, that's these. But I can let B, C, or E also be the first spot, so I'm going to multiply this by 4 to get 44, and the rule is D5 is 4 times D4 plus D3, which is 44. And D6 then would be 5 times D5 plus D4, which is 5 times 44 plus 9, which is, I think, 265. In general, the rule is Dn is equal to n minus 1 times D n minus 1 plus D n minus 2. As long as you know that D2 equals 1 and D3 equals 2, you can use this to find any one that you want. That's the recursive definition.